Assalamualaikum warahmatullahi wabarakatuh.
Welcome to
our channel.
In this video, we will present about
Our research proposal.
the use of squeeze of beet as alternative to parasit pigmentation in nematode identification.
Background of research: helminthiasis disease of the intestines transmit through the soil or soil transmit helminths is an infectious disease that occurs in the human body that is still a problem of whole Indonesia because infectious helminthiasis bubble can be found is in most area in Indonesia. Globally, the World Health Organization or WHO estimates that more than 1 billion people in the world suffer from helminthiasis, or about 24% of the world population. More than 216.7 million preschool children and 516.8 school-age children live in areas where these parasites are transmitted intensively. Soil transmitted helminths infection mainly species of worms or Ascaris lumbricoides, mineworms, Necator americanus, and Ancylostoma duodenale, and flogging worms Trichuris tricura are widespread in tropical. That Beet or Beta vulgaris is a flowering plant of the family Chenopodiaceae, which has a morphology set like a tuber and is generally used as a vegetable. Red beet or Beta vulgaris can be an alternative ingredient in the examination of intestinal nematode worm eggs because it contains beta-carotene, which product orange red pigment. Research question: based on the background above, it can be formulated the following problems. 1. Is the water of the fruit of beetroot or Beta vulgaris can be used as an alternative dye in the examination of intestinal nematode eggs? 2. How to do fluid of beetroot or Beta vulgaris which can dye eggs from intestinal nematode? Purpose of the research objective: 1. Knowing that the fruit, beets or Beta vulgaris can be used as an alternative in the examination of intestinal worm nematode egg. 2. Know the concentration of water from the fruit, beets or Beta vulgaris. The optimal worms can dye eggs nematode intestine. Benefit of the research: 1. For research, the result of this research can involve the science of the alternative coloration of elastin 2% by using a comparison the concentration of beetroot water and aqueous fluid that is optimal in dyeing the worm eggs. 2. For institution was used as reference and knowledge at the Ministry of Health Science Department of Health Analysis Bandung. 3. For social as information for Laboratorium Medis or APLM about the study of alternative elastin 2% by using a comparison of concentrated water. Significance of research in developing countries, including Indonesia. Worm disease due to intestinal nematode roundworm species in the highest cause of 60 until 90%. The second is whipworm with a prevalence of 65 until 75%, and hookworm with a prevalence of 30 and 50%. Clarification of the key terms. Comparison of beet juice are the result of comparison of the concentration of beet juice and aqua gas, 1 apple 1, 1 apple 2, 1 apple 3, 1 apple 4, and 1 apple 5. Examination of intestinal nematode worm eggs are clearly about the shape and color of worm eggs in preparation that use beet juice with variation in concentration.
Chapter 2 Literature Review. Intestinal worms, or often called STH, are intestinal worms that are transmitted through the soil. Soil is an egg-grown medium to be infective. The types of transmitted helminth soil are Ascaris lumbricoides, Trichuris tricura, and hookworm, Ancylostoma duodenal, and Necator americanus, and Strongyloides trichoralis. This is picture Ascaris lumbricoides worm adult and eggs of Ascaris lumbricoides. Ascaris lumbricoides is parasitic nematode that mostly attack human, and this worm is also called roundworm or roundworm. Adult worm have a reddish or yellow-white color, elongated cylindrical shape, blunt anterior tip lengthened and posterior tip slim temperate. The life cycle of Ascaris lumbricoides starts from the release of worm eggs with feces. In favorable conditions such as warm air with a temperature of 200 to 15 and 300 Celsius, moist, sun-protected soil, the embryos in fertile eggs turn into infected larvae within 3 weeks. If humans are swallowed by infective eggs, the eggs hatch into larvae in the small intestine. The larvae enter the intestinal mucosa and are carried into the hepatic circulation and reach the alveolar tissues. This is picture of Trichuris tricura adult and eggs of Trichuris tricura. The adult Trichuris tricura worm is shaped like a whip. The anterior portion is 3 or 5 of the slim body part like the tip of the whip, and while the 2 or 5/12 posterior section is thicker like the handle of the whip. The size of female worm is relatively large compared to male worms. The life cycle of Trichuris tricura fertilizes egg removed from the host with feces. The eggs mature in 3 or 6 weeks in a suitable environment, that is, in moist soil and in a safe place. Mature eggs are eggs that contain larvae and are an infective form. Direct infection can conditionally swallow cooked eggs. The larva pass through the egg wall and enter the small intestine. After becoming an adult, the worm descends into the distal intestine and into the colon, especially the cocoon. And next, this is hookworm, especially species of Necator americanus and Ancylostoma duodenal. The body shape of Necator americanus usually like a letter S, while Ancylostoma duodenal is like a letter C. The oral cavity of these two types of worm is large. Necator americanus has chitin, while an ancylostoma duodenal has 2 pairs of teeth. The life cycle of hookworm. In conditions of sandy soil with an optimum temperature, eggs grow and develop after 1 or 2 days, releasing Ramadhanty larvae measuring 250 to 300 micrometer. After that, it will change into infective larvae, namely filariform, and which can penetrate the skin and can live for 7 or 8 weeks on the ground. And the last is a picture of Ramadhantyform and filariform from Stercoralis trogloides.
Qualitative stool examination. 1. Native examination or direct. Native methods are used for quick and good tests for severe infections, but for mild infections it is difficult to find eggs. 2. Sedimentation concentration check. The principle of settling using a liquid that has a specific gravity which is lower than worm eggs so that the worm eggs will settle. 3. Floating concentration check with saturated salt. 4. The Parasit and Banks method. Benefit of beets. According to some of the nutrients contained in the beetroot, namely vitamin A, B, and C with high water content, besides vitamin, beetroots also contain carbohydrate, protein, and fat, which are useful for health. Besides that, there are also some minerals contained in beetroot such as iron, calcium, and phosphorus. In this case, beet work in an amazing way to stimulate the circulation system and help with red blood cells. Beets also cleanse and strengthen the blood so that blood can carry nutrients throughout the body so that the number of red blood cells will not decrease. In Eastern Europe, beets are so well known that they are used for the treatment of leukemia.
Research design. In this study of the observed variables were clarity about the shape and color of worm eggs in preparation using a ratio of beetroot juice concentration and aqueous 1/1 with concentration variation and eosin 2% as a control. The design of this study uses statistic group comparison, which is a group subject to certain treatments. Then the effect of each variation of the staining time is observed. Size and population. The population used beets in a traditional market and the sample is pressed and pressed beetroot. A total of 500 grams is measured first. The number of experimental units calculated based on replication according to rules Gomez in 1990 is I, E, T-1, T-1, R-1 greater than 15. Information T for treatment, R for replication, 15 for degree of freedom. So, we will get replication following is 6-1 R-1 greater than 15, 5R min 5 greater than 15, 5R greater than 15 plus 5, and R greater than 4. Data collection and technique. This study are used primary data obtained from the result of optimization tests on the use of beetroot juice various concentration with 1/1, 1/2, 1/3, 1/4, and 1/5 on the examination of worm eggs. Tools and material. The tools include 1. Microscope, 2. Dropper's drops, 3. Filter paper, 4. Tissue, 5. 500 milliliter of beaker, 6. Sticks, 7. 500 milliliter of Erlenmeyer, and next object glass and desk glass. And the materials include 1. Aquades, 2. 2% solution of eosin, 3. beetroot juice, and then sample pieces with alcohol.
Okay, let's go to the step. First, production and eosin. Eosin was used as control, made by 2 gram eosin dissolved in 100 milliliter aqueduct. Next, make a beetroot juice. First, weigh the fruit, cut the edge of fruit, wash it, separate the skin of this fruit, cut the fruit, blend it, squeeze using a sieve. To now find out how much percentage of beetroot juice, use this formula. Beet squeeze divided by beet juice multiplied by 100%. Okay, next, processing the beet extract. Drop 10 drops of beet extract and 10 drops of distilled water. After that, homogenize. After homogenize, make dilute again with a ratio 1:1, 1:2, 1:3, 1:4, and 1:5. Next, examination the control. First, take a sample, place it into an object glass. Discard leftovers, add 3 to 5 drops of eosin, homogenize eosin with phases, cover it with that glass, observe under a microscope. Okay, let's go to our research method. The coloring seems like the control coloring, but the eosin solution is replaced by diluted beetroot juice according to the ratio 1:1, 1:2, 1:3, 1:4, and 1:5. Finish! Yay!
Thank you for your attention.
Don't forget to like, comment, and subscribe.
See you next time!